Okay, we are officially in fractions. So, when we're dealing with fractions, all they are showing equal parts of a whole number. Equal parts of a whole number. Meaning, if I were to have this whole piece of paper and I were to fold it into two parts that are the same size, I now have one part from here and one part on here that equal a whole part. There are two parts in all. This is one out of those two parts. This is another out of those two parts. Okay? If I were to fold it again, I now have 4 equal parts. This is 1 out of 4 of those equal parts. This is 1 out of 4 of those equal parts. This is 1 out of 4 of those equal parts. This is 1 out of 4 of those equal parts. Also, this is 2 out of those 4 equal parts. Okay? So whenever we're talking about fractions, all we're talking about is how many there are in all and how many of each little piece we're focusing on. Fractions are made up of 2 things. Fractions have a numerator, which goes on top of the line. We draw a line underneath it, and underneath it goes the denominator. The numerator represents the parts. It shows the equal parts. The denominator shows the whole number. So if I were to go like this, I have a bunch of markers here. How many markers do I have in all? 1, 2, 3, 4, 5, 6. What if I wanted to find out what fraction of my markers were red? How many of my markers are red?
2.
There are 2 out of how many in all? 6. So my fraction would be that there are 2/6 of my markers are red. How many of my markers are black?
2.
1.
1. Oh.
I know they've got a black hip, but I mean like the actual color. 1, oh, and that on the screen looks a little darker. 1 out of 6 is black. 1 out of 6 is teal-ish. 1 out of 6 is orange, okay? So that's showing my parts of the whole. When I'm writing it, 2 out of my 6 markers are red. That is the actual fraction for it. But we have something called equivalent fractions, meaning different fractions can actually represent the same amount. They might have larger denominators, but we can change them and move them. This is where our knowledge of factors and multiples come into play. That's why we started with those. In the real world, I never go and say, can I have 2/6 of a cookie, please? Usually I use the smallest fraction. Sometimes I'll ask, can I have half of that? Or, you know what, I just want 1/4 of that. Or, you know what, can I have 3/4 of that? Those are the main fractions that I use. 1/2, 1/4, 3/4. There are plenty others that we don't use as often, but fractions can be moved around. 2/6 can be changed. One way is by looking at each number and seeing if they share a common factor. If they are both even numbers, they both have a common factor of 2, meaning I can make these smaller by dividing them by 2. Now, the rule is whatever I do to one, I must do to the other. You will never, ever, 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 ever multiply the top by 3 and the bottom by 2, or vice versa. It will always be the same thing. So if I were to look at this fraction and go, well, can I make this fraction smaller? My answer would be yes. If I were to make this fraction smaller, what could I do? Well, 6 can be divided by 2. 6 has a factor of 2 and a factor of 3. 2 also has a factor of 2, but not a factor of 3. They both have to share the same factor. So I'm going to be able to divide them by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So 2/6 and 1/3 are actually equivalent fractions. Now, there are some fractions that I will never be able to make smaller, like 2/3. Do they share a common factor? No. 3 can only be divided by 1. 2 can only be divided by 2. So I can't make that any smaller. Now, can I make it bigger? Totally. All I have to do now is just pick. How do I want to do it? I can make it bigger by multiplying by 2. I can make it bigger by multiplying by 3. I can make it bigger by multiplying by 4. I could choose however I want. If I were to multiply by 3, 2 times 3 is 6. 3 times 3 is 9. Okay, I just made 6/9. I could also choose to multiply 2/3 by 2. 2 times 2 is 4. 3 times 2 is 6. So 2/3 can also equal 6/9. 2/3 can also equal 4/6. So these are all equivalent fractions. They would show the same amount. Another way to look at it is like this. Here's a half. Here's 2/4. 2/4 equal 1/2. If I have 1/2, that could then be divided into 2/4. What do you think I could divide my 1/4 into? Yeah, I could put them into eighths. 1/4 could then become 4/8. And you see they are all the same size when put together. If I had a cookie, would I rather have half the cookie or an eighth of a cookie?
Half.
Technically, I want the whole thing because I quit my diet January 2nd. But when you look at it, 4/8 is the same as 2/4 is the same as 1/2. So these are what we call equivalent fractions because they are the same size. Could I put in 2/3? Would that fit? No, because they do not share the same factors. They would not work together. Okay? So that's showing the actual difference there in our fractions. So now let's do some practice. Let's say I have the fraction 6/8. And I want to find an equal fraction to it. I always want to try and make them smaller first. So the first question I ask myself is, can I make this smaller?
Yes.
Yes. My second question is, can it be divided by 2?
Yes.
In this case, yes. So that's what I'll do. If I divide by 2, 6 divided by 2 is,
3,
and 8 divided by 2 is,
4,
there we go, 3/4. Now, what if I had 9/12? My first question is, can I make it smaller?
yes.
Yes, I can. My second question is, do they share a common factor? Can they be divided by 2?
No.
No. 12 can. 12 has a factor of 2. 12 divided by 2 is 6. Cool. 9 is an odd number. 9 cannot be divided in half. There will be a remainder. There's no remainders in fractions. What's another way that I could evenly divide? 3. So 9 has a factor of 3 and 12 has a factor of 3. So if I were to divide by 3 for both of them, 9 divided by 3 is,
3,
and 12 divided by 3 is,
4,
well, look at that. 6/8 and 9/12 both reduce down to 3/4. They are equivalent fractions. They are showing the same amount. And I bet if I got my little fraction stickers, that would show that 6/8 and 9/12 show the exact same thing. That's what makes this the most confusing, is that you can think these numbers are all different when in reality they match up. So here's 3/8, 4, 5, 6. Here's my 6/8. And what do you want to bet? That the 12s, the 9/12s are going to be the exact same size. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I were to line these all up, I bet you $1 that they are all going to be the same. Looks like it. Yep. So that's where fractions can be tricky and a little deceiving. So let's try some more. What if I've got something like this where it shows 2/3 on number 1. It's telling me what it wants me to multiply it by. So it is showing 2/3 equals blank over blank. And it shows times 3 on both sides. That means I'm multiplying the numerator and the denominator by 3. So what does this fraction turn into? 6/9. Good. What about 5/10? And it's showing that it wants me to divide by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Now here's a fun fact. 1/2 is half, right?
Yeah.
We all know what half means. Another half is 2/4. Another half is 3/6. Another half is 4/8. Another half is 5/10. Another half is 6/12. Another half is
7/14.
or 8/16, or 9/18, or 10/20. Anytime you see that your numerator and your denominator are basically a doubles fact. If your numerator, if like 5 plus 5 is 10, 6 plus 6 is 12, all of those show and can be reduced down to 1/2. No matter what. 100 over 200. 150 over 300. All equals half. It's just different numbers.
Could you do that like with 3, or is it just for halves? Could you do that like with the other numbers, or just for 2 itself?
Just these fractions alone all equal half.
Oh, just those are.
Anytime you see that your bottom number is double, that the denominator is double the numerator, you know that's showing half. Okay? So now on number 3, it's showing me 5/6 equals blank over 12. So it's giving me something that's already happened. So now I have to figure out, how did my denominator change from a 6 to a 12? How did it change?
Times 2.
I had to multiply by 2. And whatever happens to the denominator happens to the numerator. So that means the 5 is going to be times 2 as well, which is
10.
10. Cool. What if I was given this? 5 over 5 equals 1 over blank.
5.
So, let's say,
One whole.
okay, so no matter what, anytime the numbers match, anytime your numerator and your denominator are the exact same number, that equals 1 whole. Because basically it's like saying, here's a marker, and this marker has been chopped up into 12 pieces, and I took 10 of them and scooted them over there. You can't think of it, it's a little unfair to do it this way, because these are separate markers that I'm now dividing by color. But really, what we're talking about with fractions is that we are taking one whole thing. That's why a cookie is a really good example, because it's one whole thing, and breaking it apart into pieces. And then those pieces are grouped. So if all my pieces have been put back together by some Crayola magic, I am back now to having one whole. So if I'm ever given something like this and it wants me to finish it, whatever the number gives me, I copy it. 5 over 5 equals 1 over 1 equals 3 over 3 equals 2 over 2 equals 180,000 over 180,000. Doesn't matter. Whatever the number is, if you see it twice, it is one whole. That's the only time you will ever use a full-on number. Okay? Those are kind of tricky too. So let's say that 10/12. What if that 10/12 was now this? It gives me the numerator but not the denominator.
Divided by 5.
So how did that 10 become a 5? Well, divided by 2. So that means I have to do the same to the 12. So to 12 divided by 2, 6. 5/6. Now, when I look at the at the fraction 5/6, is that something that can be reduced?
No.
No. They do not have common factors. And in this case, 1 cannot be used. Because if that were the case, then yes, they would have. But in this case, we can't do 1s. Because it would just give me the same thing. 5 divided by 1 is 5. 6 divided by 1 is 6. So I would just get the same fraction. Okay? Are we starting to get the hang of this? Yes. Okay, so we understand that fractions can be manipulated by either multiplication or division. And that I have to ask myself a series of questions. Can it be made smaller? Because I always want it to be smaller, because no one goes into a store saying, I'd like 9/18, please. No one says that. I want half. You go to the grocery store and you go to the fish market and you ask for 4/12 of a pound, he's going to look at you like you're crazy. So, we always want to try and make them smaller unless the directions say to make it bigger. And if the directions say to just show an equal fraction, write an equivalent fraction for what I've given you, that means you can go crazy and do whatever you want. As long as you do it to both numerator and denominator, okay? They stay the same no matter what. And the numerator is always smaller. Okay? I would never have a bigger numerator, because then if I have one whole marker, but my fraction said 11 over 10, 11 tenths, Well, that means the other marker that I cut up into little pieces, a little piece of it is stuck over on the end of my marker and I have more than a hole. It won't work. We can't do that. Okay? All right.